I'm Professor Stugard, and today I want to talk about kind of an odd statistical phenomena that's sometimes called either the baseline fallacy or the prosecutor's fallacy. But I'm going to frame it in terms of a question that you might already be familiar with. So, I live in Connecticut. I'm outside almost all the time. One day, I'm looking and I see while I'm taking a shower that I have a tick bite. So I call my doctor, I make an appointment, and I go see my doctor and I say, "Hey doc, I found this tick bite and I'm concerned about Lyme disease because I live in Connecticut." And the doctor goes, "Well, the Lyme disease test is 95% accurate, so I'm not going to order the test." Wait a second. Why didn't my doctor test me for Lyme disease? Well, the first question we should ask ourselves, because this is kind of odd. I have a test that's 95% accurate. That's pretty good, right? That's good enough for an A in my class. Why isn't that good enough to test me for Lyme disease? Well, the first question we need to ask is, how prevalent is Lyme disease? Now, according to the CDC, there were 1,869 reported cases of Lyme disease in Connecticut in the year 2018. Now, reporting Lyme disease is actually a voluntary process. The doctor is under no requirement to actually tell anybody that you have Lyme disease. It's not required by the CDC to share your personal medical info like that, even if it's aggregated in the total number of cases. So the CDC said, well, since it's not required, it could possibly be up to 10 times higher. We don't really know. We're guessing. So that would mean that it's possible that it's almost close to 19,000 cases. Well, all right. So it's got to be probably somewhere in the middle. Now, the population of Connecticut is about 3.5 million people. So this means that if I'm figuring out the probability or the rate of Lyme disease, the probability that somebody has Lyme disease in Connecticut would be the 18,690 divided by 3.5 million, which is approximately 0.00534, or about 0.5% of a chance. There's about 0.5% of a chance that somebody in Connecticut has Lyme disease. Well, I don't know about you, but that feels low to me, doesn't it? I mean, personally, I know my next door neighbor, my coworker, my wife's friend's daughter, they all have Lyme disease. I hear about it all the time. I live in Connecticut. It can't be 0.5%, can it? Well, there's a few things going on. First of all, selection bias. I am outdoors. I am active. So I have self-selected to be part of the population that is definitely much more susceptible to Lyme disease. That's just the truth of the matter. So I'm going to see Lyme disease probably much more frequently than people normally would. Also, there's a bit of a confirmation bias going on too. You know, I hear all the time of people who have Lyme disease, but I don't hear from the people that don't have Lyme disease, do I? That would be kind of strange, wouldn't it? Hey Joe, did you catch the Yankees game yesterday? Yeah, I did. Our relief pitching really sucks. Oh, by the way, I didn't get bitten by a tick. Oh, what a normal and natural thing to add to our conversation. Thank you. All right, that would be a little ridiculous, right? We don't talk about things when they don't happen. We only talk about things when they do. So you're going to have a confirmation bias there as well. Now, the thing is that, the actual confirmed rate of Lyme disease in Connecticut is 0.035%, which means it's actually way lower than this estimate here. So yeah, that's actually a bit lower. But like I said, I have all my biases, and although I'm aware of them and I should deal with them, to help illustrate this point, at least at first, I'm going to actually assume that the Lyme disease is twice as common as 10 times more common than it's reported. So if I assume it's 20 times more common than it is actually reported, that means that the probability of having Lyme disease is actually 1%. Like I said, this is not the right percent. The real percent is actually quite a bit lower. And we'll talk about that in a second. But let's say it is 1%, which is, again, like I said, an upper estimate. But if it is 1%, again, we're going to look at visually why my doctor's not going to test me for Lyme disease? Because let's say I have 100 people. All right. Well, if there's a 1% chance that I have Lyme disease, that's 1 out of 100. So one person out of 100 is going to have Lyme disease. Now, we also know that the test is 95% accurate. Well, the other half of that is that if something's 95% accurate, it's 5% wrong. That is our complement rule in statistics, which, again, that's the formula there. The probability of e to the c equals 1 minus the probability of e. That's the form of mathematics, but again, all that complement rule really states is that if you're 95% accurate, you're 5% wrong. It's really simple, right? The complement rule makes a lot more sense than we necessarily make it out to be sometimes. All right, well, if it's 5% wrong, that means that out of 100 people, if I test those 100 people, then 5 of those tests are going to be incorrect. There'll be 5 mistakes. So, going back to my group of 100 people, my one guy in orange has Lyme disease. I have 5 that have tests that did not go correctly, except again, we know the rate of Lyme disease. So those tests are all going to be false positives. There's going to be 5 people out of 100 that test positive for Lyme disease that don't actually have it. Now, you might actually see where this is going already, but if I just look at the people now that tested positive and ignore everybody else, well, I have 6 people that tested positive, but out of those 6 people that tested positive, I have 1 true positive and 5 false positives, which means if you tested positive, the probability that you actually have Lyme disease is actually 1 out of 6, or about 16.7%. Well, wait a second. The test is 95% accurate. But if I test positive, you're telling me I only have a 1 in 6 chance of actually having the disease? Well, yeah, that's how statistics works. And that's how especially uncommon things can produce very unintuitive results. And so, again, this is a matter of making sure that you can see concepts from different perspectives. Right? The ability to hold 2 different perspectives in your head at the same time is the sign of intelligence, right? I think that was like literally Aristotle, getting close to 3,000 years ago that we figured that one out, right? So we consider this from both possibilities, and this is what is called a conditional probability. Because depending on your perspective, depending upon your condition at the beginning, it's going to change the outcome of this probability. So from your perspective, you as an individual, you have Lyme disease, you take the test, your results are going to be 95% accurate. You like the sound of those numbers, right? So again, the probability that you test positive for Lyme, given that you have Lyme disease, is 95%. And again, that's the conditional part, right? Whatever comes after that word given. So the condition is that you already have Lyme, your test is 95% accurate. So that's the probability. The probability that you test positive, given that you already have Lyme, is 95%. Now, from your doctor's perspective, we switch it. For your doctor's perspective, if the test comes back positive, there's a 16.7% chance that person actually has the disease. So the probability that someone has Lyme disease, given that they test positive. So if the condition is that you've tested positive, well, then your probability of having Lyme disease is only 16.7%, and that's how the doctor sees it. Except, again, remember, that's with all my biases put in. Really, the accepted rate of Lyme disease is 1 out of 1,000 people. So if I test 1,000 people, and I have 1,000 dots here on my screen, 1 person would test positive, that's the orange, and we would expect 50 false positives. So again, that's 5%. Out of those 1,000 dots, those red ones are 5% of those dots. And again, if I consider myself only with the people that tested positive, well, that's 1 true positive compared to 50 false positives. And again, this is the accepted rate of Lyme disease, is 1 in 1,000. Which means, really, from the doctor's perspective now, if we have 1 true positive and 50 false positives, then the probability that someone has Lyme disease, given they test positive, is only 1 out of 51, which is less than 2%. Which again, so from the doctor's perspective, if you test positive for Lyme, there is less than a 2% chance that you actually have it, even though the test is 95% accurate. And again, this is called the Prosecutors Fallacy because, well, you could probably imagine how this could get argued in court, that well, no, I have this method called fingerprint analysis, and it's a 95% accurate that these fingerprints match. Huh? And again, if there's 3 million people in the state of Connecticut, how many people would match that fingerprint? So, the moral of the story is if you get into legal trouble, make sure your lawyer understands statistics. And also, again, like I said, try to make sure we can see things from a different perspective. Because again, these conditional probabilities produce very unintuitive results, don't they? So, if your doctor decides not to test you for Lyme disease, don't get upset. Hopefully we understand why that is. And of course, every doctor is different, right? I had the same exact case, and I went to my doctor. I said, I have a tick bite. Should I get tested? He goes, no, I'm not going to test you. And this is the reason. The conditional probability, the test would tell me nothing. So if you end up with a headache or a fever over the next few days, let me know and I will put you on the medicine. Now, on the other end of the spectrum, my wife's doctor said something a little bit different. The wife's doctor said, oh, you got a tick bite? Nope, tricycline for everybody. Just go on it. Just take the antibiotics. Go for it. Do it. Just be safe. Okay, well, there's that perspective too, right? And that's the point of having a doctor, right? That's the noise in our regular lives. That's the randomness of life, is that different doctors are going to do for different things. Example, past one of my coworkers, she said, well, wait, the doctor tested my family. They tested my husband and my son. He did run the tests. And again, that's perfectly valid too, right? The doctor might choose to run that test. That doesn't mean it's right or wrong or anything else. Again, it's just a matter of perspective and what the doctor thinks is best. Because again, you know, the test is 95% accurate. Are you going to test every single person? Well, no. So again, the real answer lies somewhere in the middle, and you have to make sure that you have a doctor that you feel comfortable with it. Correct? Because that's really all life is about, is making sure that you feel comfortable with what's going on. All right. So I hope this helped. I hope this was kind of interesting, and well, good luck studying.